After discussing reference directions in Lecture 4, we introduced KCL and KVL in Lecture 10. In this lecture, we will combine the two parts of knowledge and introduce a general method for solving the circuit called 2B method. The so-called 2B means that we can write 2B equations for the circuit with B branches, then find B currents and B voltage of the circuit. Next, we discuss a specific process of 2B method by taking an example. We have met the circuit in Lecture 10. There are 12 variables need to be solved because it has 6 branches. We need to list 12 equations. These 12 equations can be divided into two categories. One is written according to the element constraints. Another is written according to the topological constraints. First, let's talk about 6 equations written by element constraints. Let's look at branch 1. We'll assume that the voltage and the current are with associated reference directions in these 6 branches. That is to say, for branch 1, unmarked reference directions of the voltage is like this. We write KVL equation for branch 1. It is easy to know that U1 equals I1 times R1 plus US, where U1 and I1 are unknown. Analogously, we write element constraints equations for branch 2, 3, 4, 5, and 6. They are all Ohm's law equations under associated reference directions, where U2, I2, U3, I3, U4, I4, U5, I5, U6, I6 are unknown. Now we get 6 independent equations with 12 variables. We need other 6 independent equations to find these 12 independent variables. So we need the topological constraints. We need to consider the number of branches and nodes. The topological constraints are KCL and KVL. For this problem, it has 4 nodes. We can write node current equations respectively. For example, for this node, we call it A. Its equation should be I1 plus I2 plus I5 equals 0. The sum of all currents flowing out of the node is 0. For node B, we write the equation according to the similar method. Minus I2 plus I3 plus minus I4 is equal to 0. This node C, the sum of currents flowing out is also 0. We can write the equation that I4 plus minus I5 plus I6 is equal to 0. For this node D, analogously, minus I1 plus minus I3 plus minus I6 is equal to 0. We got 4 KCL equations now. Now the question is whether these 4 KCL equations are independent. Look at them carefully. They are not independent apparently. We add the 3 equations. I2 is cancelled. I5 is cancelled. And I4 is cancelled. We get I1 plus I3 plus I6 is equal to 0. This equation and this equation are the same. So only 3 of the 4 equations are independent. Then we'll write the KVL equations. For the circuit, we first write KVL equations from the viewpoint of the mesh. We call this mesh 1, for example. This is mesh 2 and this is mesh 3. We write the KVL equation for mesh 1. That is minus U1 plus U2 plus U3 is equal to 0. We write it in clockwise direction. For mesh 2, minus U2 plus U5 plus U4 is equal to 0. For mesh 3, minus U3 minus U4 plus U6 is equal to 0. Except for the mesh, it has other loops, such as this. It is a loop. Can this loop provide another independent KVL equation? Let's verify it. Minus U1 plus U5 plus U4 plus U3 is equal to 0. Do you notice that this equation is a sum of these two equations? You can continue to study that all equations which are written along other loops are not independent. For this problem, we can write only 3 independent KVL equations. You may have a question that, for a circuit, how many independent KCL and KVL equations can we write? We give the answer now. In general, for any circuit with B branches, if we want to get variables for all branches, that is, all B currents and B voltages, we need to have 2B equations. This is the origin of the name of 2B method. The 2B equations are composed of two parts. One part is B independent element constraint equations. We just wrote them. Another one is the topological constraints. We can write n-1 independent KCL equations. For this circuit, n equals 4 and b equals 6. So we can write n-1 equals 3 independent KCL equations. In addition, we can also write b minus n plus 1 independent KVL equations. b minus n plus 1 equals 3 in this circuit. So we can write 3 independent KVL equations. This conclusion is correct and can be proved. This is obvious and can be proved easier. But for the third conclusion, it needs to use the knowledge of the graph theory. You can refer to the relevant books if you want to know it. So with this method, we can find all 2B branch variables of any circuit through writing the element constraints equations, KCL and KVL. So circuit analysis can be implemented in a standard form. But it needs to be pointed out that we need to write 12 equations to solve such a not so complicated circuit. The workload is unbearable. So this method has much theoretical significance than application value. In the next several lectures, we will introduce more practical methods and techniques to help you solve the circuits quickly.